Namaste. In this session, I will teach you how to identify chlorine, bromine, and iodine compounds in LCMS having seen the LCMS spectrum. LCMS system and components workflow diagram. The four vital components of any LCMS system are: first is the HPLC, second is the ionization source, third is the mass analyzer, fourth is the mass detector. Mass detector is responsible to produce the mass spectrum. In this session, I will teach you how one can say whether a compound contains chlorine atom, bromine atom, or sulfur atom or not, having seen the MS spectrum. Isotopic number. The atomic number Z is the number of protons in the nucleus. It determines the identity of an element. Atomic mass or mass number. The mass number A is the total number of protons and neutrons. Mathematically, we can write mass number is the number of protons and number of neutrons. Isotopes. Isotopes are atoms of the same element that have the same number of protons but different number of neutrons, therefore different atomic masses. Since isotopes have different masses, they produce additional peaks in mass spectrum, which we are going to discuss in this session. Isotope peaks in mass spectrometry. Naturally occurring isotopes produce characteristic isotope peaks: M molecular ion peak, M plus 1 mass unit higher, M plus 2 mass units higher. Most elements produce only very small isotope peaks, but chlorine, bromine, and sulfur produce distinctive isotope patterns that are extremely useful for identifying these atoms in any unknown compound. Chlorine isotope patterns and natural abundance. Since the isotopes differ by 2 Dalton, chlorine containing compounds always show 2 molecular ion peaks separated by 2 M by Z units in LCMS spectrum. Characteristic pattern: M is to M plus 2 ratio approximately 3 is to 1. This ratio is a diagnostic for one chlorine atom. This is the abundance of the both chlorine isomers, approximately 75 is to 25. Now I am going to explain presence of chlorine atom in the structure, taking example of 4-chloroacetophenone. This molecule can easily be analyzed in ESI positive mode. Then first I will discuss M plus H M by Z peak for each isomer. The precursor ion M plus H for chlorine with atomic mass 35 will be 155, since its molecular weight is 154.59, and M plus H for chlorine atom with atomic mass 37 will be 157, and its ratio is expected 3:1. LCMS spectrum also confirms the same, means it confirms the presence of chlorine atom in the structure. Typical fragmentation pathways. Major fragment absorbed M by Z 140 and 142. It is due to loss of CH3. LCMS also confirms the same. Second fragment is observed at 113 and 115. It is loss of CH2CO. Alpha cleavage adjacent to carbonyl produces M by Z 43. LCMS spectrum also confirms the same. Interpretation. Peaks separated by 2 M by Z, approximately 3:1 intensity ratio observed in the spectrum, indicates one chlorine atom in the structure. Bromine isotope pattern. Natural abundance. Because both isotopes occur in nearly equal amount, bromine produces one of the easiest isotope pattern to recognize. Characteristic pattern: M is to M plus 2, approximately 1:1, and this is the actual ratio. Now I am going to explain the presence of bromine, taking the example here 4-bromostophenone. Its molecular weight is 199.04. Molecular ion peak, that is M plus H, is equal to two prominent molecular ion peaks at M by Z 199 and 201 expected with ratio 1:1. LCMS spectrum also confirmed the same, means presence of bromine atom in the structure. Major fragment M by Z 184 or 186. It is loss of one methyl group from the structure. LCMS also confirms the same. M by Z 155 and 157. Subsequent loss of carbon monoxide. LCMS spectrum also confirms the same. M by Z 76 and 77. Phenyl or phenyl hydrogen ion after the bromine atom cleavage. LCMS spectrum also confirms the same. Interpretation. Peaks separated by 2 M by Z, nearly equal intensity in the spectrum, strong evidence of bromine atom in the structure. Spectrum also confirms the same. Sulfur isotope patterns and natural evidence. Sulfur is only other element common to organic compound that gives a signal M plus 2 peak. that is 95.02, sulfur 34 about 4.21%. It also gives sulfur with atomic mass 33 0.8% and M plus 1. It is expected only because M plus 1 peaks are relatively low in intensity compared to molecular ion and often difficult to measure with any precision. They are generally not useful for accurate determination of molecular weight. 4-methyl sulfonic acid. Now I am going to explain taking the case example of this compound. Its molecular weight is 172.2. This compound can be analyzed in ESI negative mode. Then what will be M minus H? M minus H precursor ion will be about 171.1. LCMS spectrum also confirm the same. Second fragment is 95, which is loss of CH3SO3 minus. LCMS spectrum also confirm the same. Next is the 80, which is loss of SO3 minus. LCMS spectrum also confirm the same. In the same way, other fragment can also be explained. Summary of isotopic patterns. This is the summary of chlorine, bromine and sulfur. Expert tips: always inspect the M, M plus 1 and M plus 2 peaks in the mass spectrum. A 3:1 M is to M plus 2 ratio strongly suggests one chlorine atom. A 1:1 M is to M plus 2 ratio is highly characteristic of one bromine atom. A small 4% M plus 2 peak may indicate one sulfur atom, but it should be interpreted together with accurate mass and fragmentation data. This is all about this video. For any clarity related to this tutorial or Pharma Guru course, you may write at this email or you can contact at this phone number. Thank you. Let us see you in the next session.